I want to show you an example of a high-speed video I took. This is a whip cracking. And I want you to notice how fast the tip gets moving. As this loop progresses down the whip, that tip gets going really, really fast. It breaks the sound barrier. That's what causes the crack. It's a miniature sonic boom. Here's it going a little bit slower even. Notice how fast that tip gets going. Okay, so I want to show you a tool that we can use to actually quantitatively analyze high-speed video. So I'm going to, this is Logger Pro, by the way. The program is called Logger Pro. I'm going to bring my video into the program. And I'm going to get it. So this is nice. I can play the video in here. I can also just go frame by frame if I want to. I'm just going to try to get this right to about where it's going to crack. So it cracks right about there. Go a couple more frames past that. Let's see. One right there. So the first thing I need to do is I need to tell the computer, or tell this program, a relative distance so it can make measurements. And I know that that length of the whip from this knot down here to that knot up there is very close to 0.5 meters. This is not going to be perfect, by the way. If I were doing this for real, trying to be really, really accurate, I would definitely make this a little bit more precise. I need to make one or two other changes here. I need to say that the frame rate is whatever it was, which in this case was 1,000 frames per second. And now I'm going to back up to right about there. And I'm going to start putting some points down. So you can see the whip, of course, goes to there, but it actually doesn't end there. Maybe you can kind of see this. This is a sort of white string here. This is the cracker of the whip. And it ends in a little white sort of poof of string right there. So I put a point down there. And when I put a point down, it will automatically advance to the next point in the slide, which is really hard to see. But we're not being quite perfect. We're trying to be close though. Okay, so I'm just following that same point. So it goes up to here, into there. Okay, so you can see kind of the trajectory or the path that we're taking here. And hopefully it's clear where we're moving the fastest, right? Each of these increments is 1/1000th of a second, and this is the biggest distance. So that's where we're going the fastest, right there between, let's see, 1, 2, 3, 4, between points 4 and 5. That's all great. I'm going to come over to here, and this actually tells me automatically some of my characteristics like location, coordinates, so x and y, and then velocities, x and y velocity. I don't actually like the way that this program is calculating velocity, so I'm going to just take that data, which is good, and bring it into my Excel program and paste it in another point here. And I can see for each of those points exactly how fast I'm moving. So this is my calculation of velocity. I think it's a little bit better. And my maximum is right there, 368 meters per second. That's meters per second. That is faster than the speed of sound. The speed of sound is about 340 meters per second. So there I just showed, again, it's a fairly rough calculation because I wasn't being perfect, but it showed that the tip of the whip was going faster than the speed of sound. I broke the sound barrier, and that was that crack, that little small sonic boom. So cool. Plenty of other things you can do with this software, but this is just sort of to give you an idea.